Hi guys, welcome to Simple Programming. In this video, let us see how to use DynamoDB in Spring Boot application. DynamoDB is a document-style database. In other words, semi-structured database. It has a capability to scale depending upon the size of data. For example, if the size of your data in the table keeps on increasing, right, it automatically scales depending upon the size of the data. And it supports 35 levels of nesting on the data. You can have 35 levels of nested objects within your data. This data is stored in solid state drives and is spread across 3 geographical data centers. So your data can never be lost when you use a DynamoDB. You can use DynamoDB directly from the cloud environment, or you can use the DynamoDB local, a downloadable version provided by Amazon. So if you are looking forward to use the downloadable version of DynamoDB, right, you can go to this location and download this and install in your machine and use DynamoDB just like a local database. In this example, we are going to directly connect and work with the cloud version. So in order to work on this AWS console, you need to create an AWS account to access this AWS console. The account creation process is very simple and straightforward. So once you've created an account, you'll be routed to this home page. And in this home page, you have multiple services offered by Amazon Web Service. In this multiple services, scroll down and you will be able to see a category called database. In this, click on DynamoDB. Alright, once you go to the DynamoDB console, click on Create Table. Give a name for your table. I'm going to name my table as student. So we have the partition key here. So DynamoDB supports 2 types of primary key attributes. One is a single attribute, which is the partition key or the hash key. The other is a composite attribute, which is a composition of hash key plus range key or the sort key. This hash key, a partition key, is used to calculate the hash value, which is then used to determine the physical location where the data will be stored. No two keys can have same values in a single attribute combination. Whereas in case of a composite attribute, which is your hash key plus your sort key, 2 items can have same hash key but different range key. The sort key is completely optional. If you want, you can add it. In this case, I'm going to add this. So I'm going to name my hash key or the partition key as student ID, and I'm going to add my sort key. The sort key or the range key is going to be the last name. Click on create, and the table is now being created. The table has been successfully created. If you scroll down, you'll be able to see the partition key and the primary sort key here, and then the default values with respect to different elements in the DynamoDB. If you click on the Elements tab, you'll be taken to the table where your actual data is going to be stored. As of now, we have only 2 columns mentioned, that is the student ID and the last name. So before we go to our IDE and start coding, let us quickly go on to the IAM console. IAM console is nothing but Identity and Access Management console. We have to generate the access key and the secret access key in order to access the DynamoDB from a Java client. Let's go to our AWS console. Scroll down and you will see security, identity and compliance. In that, the first service is going to be your IAM service. Click on that and you'll be able to see groups users here. First, let's create a group. I'm going to name this group as AWS admins. Next, you have multiple roles available predefined in AWS console. So you can directly select this, or you can even create your own policy with different roles in it. So for this case, right, I'm going to select administrator access. That is, this particular group is going to have full access to all the elements in the AWS console. Click on next and create group. The group has been created. Now let us create a user and then let us add that user to this group. I'm going to name this user as simple programming. There are two types of access which you can provide to a user. Either you can provide a console access or a programmatic access, or you can provide even both to a single user. In this case, I'm going to give only programmatic access to simple programming and click on next. In the next is where you set your permissions. Since I've already created a group, right, I'm just going to map this user to this group. Click on review. Just make sure everything is fine and then click on create. Once you click on create, in the next page, you'll be able to see the access key ID and the secret access key. There is one important thing about these two elements. You should never share this access key ID and secret access key ID to anyone, because once you share, they will have access to the console either programmatically or through a either directly to a console. So never share this. In this case, right, I'm going to delete this account after this video. So make sure you copy this access key ID and secret access key and save it securely in your laptop in some secure location. Okay, let's move on to our IDE and let's try to write code for our DynamoDB database from Spring Boot application. I've already created a project with Spring Boot application, and let us quickly take a look at the form.xml. In the form.xml, I have added only two dependencies in it. One is the Spring Boot starter web in order to use the RESTful API services, and the next is the AWS Java SDK DynamoDB dependency. This dependency information can be found from the AWS documentation. So the version I'm using is 1.11.408. I think the new version is like 411 or 412. I don't remember it, but I'm going to use the version 408. Let us go to our application.java. The startup file is going to have only at the rate of Spring Boot application. Then let us take a look at our configuration. The configuration file for our DynamoDB is going to contain a series of keys in it. The key is AWS access key, AWS secret key, AWS region, and the DynamoDB endpoint. The endpoint to which our application can connect to access the DynamoDB. Then we always have to create a client for our resource or the service that you're going to access. This client is going to be same for all the services that you're going to use. For example, if you're going to access S3, right, you have to build your S3 client here. If you're going to use SQS, you have to build your SQS client here. If you're going to use SNS, you need to create the SNS client builder here. So you need to create a client builder and pass on the region, endpoint URL, the access key, and the secret access in order to create this client builder. So here's the logic for creating a client builder. You can create a default client or you can create a standard client. I have created a standard client here with endpoint configuration and credentials. And then what I'm going to do is I'm going to pass on this AWS client builder configuration to my DynamoDB mapper. A DynamoDB mapper is nothing but an object mapper for object domain interaction with DynamoDB. So this is like in a simplest term, I can give an example like this will serve like a JDBC template or a REST template or a Redis template. This is going to be a template for you to interact with your DynamoDB database from your Spring Boot application. Let us quickly take a look at our application.yaml. So this is my application.yaml, and you could see here the keys have been mentioned here. The access key, the secret key, the region, the endpoint URL, everything has been mentioned here along with the server.port. Let us take a look at our controller. I have a REST controller which is going to accept a post mapping, a get mapping, a put mapping, and a delete mapping. The implementations are pretty much straightforward. The post mapping is going to accept a request body. The get mapping is going to accept the student ID and last name as request parameters. The put mapping is going to accept the request body again. The delete mapping is going to accept the student ID and last name as path variables. Next, let us take a look at the DynamoDB repository file. The DynamoDB repository is a class file in which we are going to auto-wire the DynamoDB mapper, and then this mapper is going to give us set of different methods which you can use to access the DynamoDB. So we have a save, we have a load, we have a delete. To insert a data into database, you can simply do mapper.save and pass in the object. To get information from the database, you need to do mapper.load. You need to mention the class which is going to represent the data in the database, and you need to pass the hash key and the range key in this load so that the fetch will happen without any issues. Then we have a delete, which is straightforward mapper.delete. The last one is update. Update shares the same method as that of save. That is, in case of insert and update, it's going to be the same method, that is mapper.save. You need to figure out if the data is present in the database before you make an update. If the data is not present, then it should return an error to a user indicating that the data is not present in the database. So that check can be done with the help of a DynamoDB save expression. DynamoDB save expression, you can use this to adding multiple expressions for your needs. For example, you may want to save only if an attribute has a particular value. You can do this with the help of a DynamoDB save expression. The expected attribute value is nothing but it represents a condition to be compared with an attribute value in the database. So let us take a look at this implementation. So I have created an object for DynamoDB save expression. Then I created a hash map which is going to have a string and an expected attribute value. So the string is going to be student ID, the column of the table that I want to check, and then I'm going to create a new expected value, and I'm going to set the student ID that I got in the put mappings request body. Then what I'm going to do is I'm going to do a simple comparison operator which is going to compare this value with the value present in the database. If the student ID does not match a value in the database, then it is going to throw an exception which is conditional check failed exception, and it will return an error. So this is something that you need to do. If you don't do this right, and DynamoDB will insert a new record of the redundant data, which is something that we don't want. So it is always necessary that you make this check before you save a data. Next, let us take a look at the model. I have a student object which is going to act as a table, the student table that we created in the AWS console. So you have to annotate this class as at the rate of DynamoDB table and mention the table name. Then we have the student ID, which is the hash key, and the last name, which is the range key. So you need to annotate the student ID with at the rate of DynamoDB hash key. This student ID is going to be generated automatically. So in order to generate a key automatically, you need to mention DynamoDB auto-generated key annotation. Similarly, for other attributes, you have to mention at the rate of DynamoDB attribute. You could see here that last name has been annotated with DynamoDB range key, which is the sort key that we created. In this model, we have one special element, that is the address. This address is going to serve as an individual column in the student table. All the details that are present in the address will be stored as a JSON element in one single column inside the student table. In order to achieve that property right, you need to annotate this address class with at the rate of DynamoDB document. The other elements are pretty much same as what you did in the student. You have to annotate all the elements in the model class with at the rate of DynamoDB attribute. Let us run this example and let us try it out in the Postman. Okay, the server is up and running. Looks like our configurations have been working fine and no issues with our configurations. Let us move on to Postman. Okay, so I'm here at the Postman console, and here's the request that I'm going to send out with the student object and the address object. Once this request is sent out, it should get updated in the DynamoDB in the cloud AWS cloud environment. Let me click on send button. We have received successfully inserted into DynamoDB table. Let us confirm that by logging into our AWS console and checking the DynamoDB table. Looks like our request got successfully inserted, and when you click on the student ID value, you will get a pop-up window with the values in it. So the student ID has also been auto-generated in this case, and the values that we sent in the request are successfully got saved in the DynamoDB. Let's go back to Postman and let's try to do a get mapping now. For the get mapping, I need to provide the student ID and the last name as request parameters. So let me click on send now, and I have got the successful response from the DynamoDB database. So our get mapping is also working fine. Now let us go to the put mapping. For put mapping, I need to provide the student ID because this is the column that our logic is going to use in order to check whether the data exists in the database or not. Let me do one thing. Let me remove this value and send out the request. You will be seeing an error in this case. Alright, we didn't get any response. Let us go to our console. Do you see this? Invalid data. The conditional request failed. So this is nothing but the logic that we have written here. If the value does not match, if the value does not match, throw a conditional check failed exception. Now let us change back the value. And in this case, I'm going to change the age to 18. And second street is going to be third street. And I'm going to send a request now. Okay, the request has been successfully sent. Now let us jump back to our DynamoDB console. Let me refresh this data now. Alright, looks like our update has successfully worked. The age has changed from 18 to 19, and in the address, we have changed the value from 2nd Street to 3rd Street. So this update has successfully worked. Now let us go back to the Postman console and let us do a delete now. I think the delete has successfully happened now. Let's confirm this by going back to the console. Let me do a refresh, and the record has been successfully deleted. So this is one way of using a DynamoDB with a Spring Boot application. If you're looking for a more simplified way of accessing a DynamoDB, right, I suggest you take a look at this GitHub location. A guy named called Dergest has created a Spring Data Dynamo library which you can use to access DynamoDB. So if you use this library, right, you can make use of the CURD repository implementations, and you can, the entire logic becomes very simplified. The only disadvantage is your organization should approve the usage of this library. If they don't approve the usage of this library, right, you can use the implementation which I showed before. If they approve the usage of this library, then you can go ahead with this library, because this library makes lot of logics very simple to use, just like the Spring Data JP or Spring Data Cassandra or Spring Data PostgreSQL. So just like those different libraries, right? This library is also makes things very simple. With this, we have completed the Spring Boot with DynamoDB example. I hope you would have enjoyed this. Please subscribe and watch out for more such videos. Thank you.